Hey everyone, my name's Stanley, and today we're going to be learning about exponents. So what is an exponent? Well, in order to help visualize this, let's look at how multiplication works. Let's say we have 4 times 3. What is that equal to? Well, according to the rules of multiplication is basically repeated addition. So 4 times 3 is just 4 plus 4 plus 4, or 4 added to itself 3 times. And that's 12. What about exponents? What about 4 with an exponent of 3, or 4 to the power of 3? Well, that is actually repeated multiplication. So it's 4 times 4 times 4, or 4 multiplied by itself 3 times. And that is 64. So let's go back the slide. So what do we call the big number and the little number in the expression? The big number is the base, which is right here. And the base is the number that will be multiplied by itself some number of times according to the exponent. And therefore, this little number is called the exponent, and it determines how many times the base will be multiplied by itself. So in this case, we have 4 as the base. And 4 is being multiplied by itself. But how many times is it being multiplied by itself? 3 times because of the exponent. So using what we just learned, let's evaluate some exponents. This is basically just 3 times 3. This is because the exponent is 2, and that shows me that I want to multiply 3 by itself 2 times. So using this, we just get 3 times 3, and that's just 9. So the answer is 9. Using that same process, let's do 4 with an exponent of 3. The exponent is telling me that I want to multiply 4 by itself 3 times. So let's do that. 4 times 4 times 4. And that is just 64. So now that we know how to do this by looking at numbers, how do we do it when the question is in the form of words? Like, what's with this power and everything? Well, when you say something to the power of something, this is the base, and this is the exponent. So something to the power of something else is just the base to the power of the exponent. So in this case, this would be 5 to the power of 2, or 5 with an exponent of 2. So that's just 5 times 5. And that is just 25. Therefore, 25 is the answer. What's up with the second one? Well, the second one is basically the same thing as the first one, except something is to the somethingth power. But this is the same thing. This is the base, and this is just the exponent. So something to the something else power is basically base with the exponent as the power. So in this case, 3 is being brought to the 4th power, which is just 3 times 3 times 3 times 3. And that's 81. Now, although this might seem really long, it can actually just be broken up. For example, we know that 3 times 3 is 9. And we know that 3 times 3 is 9 here. And this is just the same thing as 9 times 9, which is just 81. Breaking long chains like these into smaller sections can help you solve the problem more easily. Now, this looks strange. Why is 0 in the exponent? Well, if you listen to what I said before, I said that the exponent actually determines how many times the base gets multiplied by itself. But how can it be that it's 0 times? Well, surprisingly, any number to the power of 0 is just equal to 1. So anything, 103 to the power of 0, all equal to 1. It could be a million. Let's say you have a million to the power of 0, and it's always going to equal to 1. Everything, anything to the power of 0 is going to be equal to 1. Why is that though? Well, let's look at this diagram here. 3 to the 4th is 3 times 3 times 3 times 3, right? 3 to the 3rd is 3 times 3 times 3. 3 to the 2nd is 3 times 3. And 3 to the 1st is 3. So how do we get 1 for 3 to the power of 0? Do you see the pattern? every time the exponent decreases by 1, the result actually decreases by a factor of 3. 3 is being multiplied by itself 4 times here. But here, 3 is being multiplied by itself 3 times. And then it's being multiplied by itself 2 times, then 1 time. So each time the exponent is decreasing by 1, like when 4 goes to 3, it loses 8 times 3. So that means that this answer is actually going to be 3 times less than this answer. So essentially, we're just dividing by 3 every time the exponent decreases by 1. So this one divided by 3 is this one. Divided by 3 again is this one. And divided by 3 one more time is this. So when 1 goes to 0, 3 divided by 3 is just 1. And that's why 3 to the 0th power is equal to 1. And this works for any number. Let's say we have 5 to the 2nd is equal to 5 times 5, which is 25. And then 5 to the 1st is just 5. And then 5 to the 0, therefore, is 1. Because 25 divided by 5 is 5. And 5 divided by 5 is 1. So any number to the power of 0 is just equal to 1, no matter how big or small that base is. Now powers of 10. So here we have 10 as a base with different exponents. Let's do it the way that we've always been doing it. 10 to the 2nd power is just 10 times 10, and that's just 100. And 10 to the 3rd power is 10 times 10 times 10, which is 1,000. 10 to the 4th power is 10 times 10 times 10 times 10, which is this 10,000. Wait, do you see a connection between the exponent and the number of zeros in the answer? If the base is a 10, then the exponent actually tells you how many zeros are going to be in the answer. 10 to the 2nd power is going to have an answer starting with 1 and then 2 zeros. 10 to the 3rd power is going to start with 1, but then 3 zeros. 10 to the 4th power is going to be 1 with 4 zeros. So it's just kind of like a neat trick when you see that your base is 10. So let's say you have 10 to the 16th power. Well, the answer is just going to be 1 followed by 16 zeros. Now it's time to evaluate. We have to find either the missing base or the missing exponent. Here, 10 to the power of something equals to 100,000. Well, since the base is 10 and it has 5 zeros, the exponent is just going to be 5. So that's the answer here. For the second one, we have 7 to the power of something equals to 49. Well, we know that 49 is equal to 7 times 7. And because 7 is being multiplied by itself 2 times, that must mean that 2 is the exponent. So 2 is the answer for the second one. Now, for the third one, we have to find the missing base. And we know 27 is just 3 times 3 times 3. And guess what? The exponent is saying that this base will be multiplied by itself 3 times. So that means 3 must be the answer here. So the answer is 3. Now, this may look more complicated with exponents with decimal bases, but it's basically the exact same thing. If we get 1.1 to the power of 2, that is just 1.1 times 1.1. It's just 1.1 multiplied by itself 2 times. So if you multiply it out, it's just equal to 1.21. And so that is the answer here. For this, we have 0.3 to the 3rd power. 0.3 times 0.3 times 0.3. You might say, hey, this is kind of difficult to do. Well, like we said before, let's split this up. What is 0.3 times 0.3? Well, that's just 0.09. And then what is 0.09 times 0.3? That is just 0.027. So that must be the answer. So now we have exponents with fractional bases. These are just the same things that we've been doing. 1/3 to the 2nd power is just 1/3 times 1/3. And as we know, when we multiply fractions, multiplying the numerators of these will give me the numerator of the answer And multiplying the denominators of these will give me the denominator of the answer. So 1 times 1 is 1, and 3 times 3 is 9. So that means this must be the answer. And same thing with the second one. 2/5 to the power of 3 is just 2/5 times 2/5 times 2/5. And the numerator of the answer is going to be 2 times 2 times 2, which is just going to be 8. And the denominator of the answer will be 5 times 5 times 5, which is just going to be 125. And therefore, that is your answer. So that pretty much sums it up for exponents. There are some questions that you can try for classwork and homework. Links in the description. Thank you so much for listening, and feel free to check out any other videos that are made by us. Bye everyone!